take a look at this. You've been taught 4 different ways to solve your quadratics. So we're going to go through all 4 ways. We'll talk about when you can use one way versus another method to try to help you figure out when you're solving them, which ones you're going to end up needing. So our first way is what we call extracting roots. Those ones are generally set up where you have simply an x squared or even an x cubed and then a number along with it. There's no x term. So like what I have here in my example, ax squared plus c, so you have your x squared, you have a number, there's no middle term. So that's when you can do what we call our extracting roots. So what you want to do is you want to get your x squared entirely isolated, and then you end up taking the square root of both sides. So if we look at our examples, number 1 is already set up perfectly for us. We have x squared equals 16. So our x squared is by itself. So in order to get that down to simply an x, I'm going to take the square root of both sides, because if you remember from last unit, squaring, square roots are opposites. So we get x equals plus or minus 4. This time the radical sign was not already there. We introduced it to solve. That's why we got to have the plus minus sign there. Because remember, when we go to do a check, positive 4 squared gives us a 16. We get 16 equals 16 for our check. Negative 4 squared also gives us a positive 16, because you would do negative 4 times negative 4. Negative times negative is a positive. So we get 2 answers with that one. And that's always going to happen with your even roots. So let's say I had, for example, x to the 4th equals 81. I would end up taking the 4th root since it was an x to the 4th, so I would take a 4th root there. That would also end up being plus or minus 3. So your even roots, you would end up getting that plus or minus sign in there. Over here, though, for number 2, we've got an x to the 3rd, so what root do we want to take on each side? Yeah, so take the cube root. So this one just ends up being positive 2. Because the only way to get an 8 would be 2 times 2 times 2. That gives you your positive 8. If I did negative 2 times negative 2 times negative 2, that ends up giving me negative 8. So that's why it doesn't happen with your odd root. Your odd roots stay whatever sign it is. So this one was positive, so it stays as a positive 2. My third example here, we could factor it, but because I only have the x squared, I'm not going to actually do that. I'm going to start off by adding my 100 over to get it away from my x squared. And then what do we want to do with that 25? Divide. So divide by 25, and we get x squared equals 4. Take the square root of both sides, and we get plus or minus 2. And then our fourth one, again, we just got that x cubed, and then we got our number, so we'll subtract our number over first. So 2x cubed equals negative 128. Divide by the 2 next. 128 divided by 2 gives us 64, so we get x cubed equals a negative 64. So then we would take the cube root of both sides. We end up with x equals negative 4. Because I was taking the cube root of a negative, my answer is also going to be negative. So again, negative 4 times negative 4 is positive, but times that third one makes it the negative again. So we get our negative 64. No, only if I was taking an even root, square root, 4th root of a negative, would we have I. Odd roots, no. All right, factoring, that is our other way we have learned how to solve our quadratics. So when factoring, we always look first to see, is there a GCF? If there is, then we take care of it. After GCF, if it has two terms, you're going to look to see if it's dots. Remember, it's got to be subtraction, and they have to be perfect squares. So exponents have to be evens, and then the numbers have to be the perfect squares. If it has three terms, then it's most likely going to be a trinomial, which is just basically a guess and check method. If it's got four terms, then it's going to be the grouping that we were taught how to do in Unit 1. So always GCF, and then you ask yourself, 2, 3, or 4 terms, that tells you what kind of factoring we do next. So taking a look at example number 1, what do we want to do first? Yeah, we're going to multiply out. But if we take a look at the things in the parentheses, what are those? Those are conjugates. Conjugates exist even if they aren't radicals or i's. Anything can have a conjugate. So it's the same thing, only one's plus and one's minus. So what happens when we're multiplying out conjugates? What do we have to multiply? Yep, conjugates. All you got to do is multiply the first and the last. 2x times 2x gives me 4x squared. Negative 3 times positive 3 gives me negative 9. Now, yes, we could solve this one like we did on the front, but I want to practice factoring. So we're going to do this using factoring. So I'm going to subtract my 7 over, because in order to factor, it's got to be equal to a 0. It's what we call our standard form. So do we have a GCF? 4. So pull out that 4. So I'm left with 2 terms now, x squared minus 4. Is that going to be a dots factor? Yes. So it's going to be x minus 2, x plus 2. And then remember with factoring, we set them equal to 0 and solve for x. So we end up with positive 2, and we end up with a negative 2. And what happens with that 4 out in front? Does it just magically disappear? No, what happens to it? Yeah, it doesn't actually equal 0. You can't set 4 equal to 0. That just doesn't work. So it ends up getting rejected. So it doesn't just magically disappear. It just ends up being rejected there. All right, number 2, kind of taking us back to last unit a little bit. We have a radical in there. So what do we do first in order to solve these? Really? Yep, subtract our 7 over. We want to get that radical by itself. So I subtract my 7 over. I end up with a negative 4 over there. Now there's 2 things we could do at this point. What's one thing we could do? We could divide by negative 1. So when I divide by both sides by negative 1, it just makes those negative signs go away. So now we'll square both sides. So on the left side, it just makes that radical go away. Right side, 4 squared gives me 16. So subtract our 16 over so we can factor. So multiplies to negative 16, but adds to give us negative 6. Negative 8, positive 2. And when we set those equal to 0, all it does is it changes their sign. So x equals positive 8, x equals negative 2. And then especially since it's a radical, you need to make sure you check, because radicals, a lot of times, things end up getting rejected. So if I put 8 in here, I get 64 minus 48. What is 60 minus 48? 16. All right. So then the square root of 16 makes that a 4. So 7 minus 4 actually 3. Yeah. All right. So negative 2. If I square negative 2, that's 4. This would become plus 12. So that makes it a 16 again. So yeah, that's going to end up working. So in this case, both of them ended up staying. But that's not always going to be the case. So you got to make sure you always check. All right, third one there. What do we want to do first? Cross multiply. We would do the x minus 2 times the x plus 9. And it will equal x minus 1 times the 2x minus 4. So go ahead, multiply those out. And then get everything onto one side so you can factor. So after you distribute everything out, get everything on one side, you should have the trinomial x squared minus 13x plus 22 that you're trying to factor. So it multiplies 22 but adds to 13. 11 and 2. So in fractions, you just got to remember, make sure that your answers don't make the fractions undefined from the original. So if I plug in 11 or a 2 up here in my originals, do I get any zeros in my denominator? No. So those are good. 11 and 2 are going to be our answers for that one. And then number 4, going back to unit 1 a little bit here. What do we need in order to be able to solve our equation? Common denominator. What would our common denominator be here? We got to multiply them. You can't just add a plus 2. So x times x plus 2 is our denominator. We have to multiply those together. So my first fraction there has the x plus 2. I got to multiply it by x. So that's going to turn into a 6x up top. My next one doesn't have any of it. So that's going to be x times x plus 2 because it's times 1. And then my third one here, I got to do times the x plus 2 because it has the x. It needs the x plus 2. So now what do we do? Cross out those denominators with the fractional equations. Once they're all the same, you cross out that denominator. So I have 6x plus x squared plus 2x when I distribute equals 3x plus 6. So you go ahead, if you haven't already, finish that up, solve for x. Let's see what we get. So hopefully you got x equals negative 6 and x equals 1. Neither of those make the original fractions undefined, so those are good. All right, next thing we're reviewing, quadratic formula. You guys remember the quadratic formula? Sadly. Quadratic formula is awesome. What is it? Sing the song. The song.
Enlighten us, please.
You don't know the song? I taught you the All right, quadratic formula. Negative b plus or minus the square root. B squared minus 4ac all over 2a. The one cool thing about the quadratic formula is it always works. No matter what kind of quadratic you have, quadratic formula will work. Factoring doesn't always work because not every quadratic is actually factorable. So you can't always use that method. The extracting roots, taking the square root of both sides, doesn't always work. Bless you. Especially if you've got a middle term in there. So if you got an x term, you can't do the taking the square root of both sides. But quadratic formula is always going to work. The one thing, though, to be careful of is it is the quadratic formula. So it only works on quadratics. I've been seeing a lot more lately kids getting a problem where it's like, for example, x to the fourth minus 2x squared minus 8 equals 0. And they're trying to use the quadratic formula on that. But this is not a quadratic because the largest exponent is a 4. So that's actually a quartic. So we can't use quadratic formula on that. The highest exponent can only be a 2. Then you can use your quadratic formula. So let's look at our examples here. First one, find the roots of the equation 3x squared minus 5x plus 2 equals 0. So let's first practice. We need to be able to identify what our a, b, and c's are. So looking at our equation, what is our value of a in this first one? 3. Not to be confused with the x squared. The values are just the coefficients. So then our b value, -5, and our c is a 2. So now we got to go ahead and plug that into the formula. Now what I like to do first with the formulas, I go through and I stick parentheses everywhere there's a variable, just so there's no mistakes when I'm plugging things in, especially when you're plugging in a negative b value. A lot of people tend to square that incorrectly if you don't have your parentheses. So our formula's up top. So we start off with, I need to put a b value there and a b value there, and then a, c, and then an a down there. So then cleaning things up, what happens with my double negative? Positive. What do we get underneath that radical? 1. Because negative 5 squared is 25. 4 times 3 times 2 is 24, so 25 minus 24 gives us a 1. And then we get a 6 in the bottom because 2 times 3 gives us 6. So is 1 a perfect square? Yeah. What's the square root of 1? 1. So we get 2 answers. We've got to do 5 plus 1 all over 6, which what does that give us? 1. And then we also have to do 5 minus 1 all over 6, 2/3. So we get 1 and 2/3 is our answer there. All right, let's take a look at our second one here. What do we need to get? Common denominator. What will our common denominator be? Yeah, multiply the two of them together. So x minus 1 times x plus 2. On the right side of my equal sign, it's just going to be x minus 1 times x plus 2 over itself because it was a 1. Anything over itself is 1. So the first fraction, that numerator of 2, what do we have to multiply that by? You got to multiply that by the x plus 2 because the bottom has the x minus 1. Missing the x plus 2. Second fraction, what do we multiply that one by? X minus 1. That gives me a 3x minus 3. So we cross out our denominator. So I combine my 2x and my 3x, that gives me 5. 4 minus 3 gives me 1. Other side, when I multiply it out, I get x squared plus 1x minus 2. So subtract my 5x over, subtract my 1. And we get the trinomial x squared minus 4x minus 3. So go ahead, plug that into your quadratic formula. It's not actually factorable, because if the 3 were positive, you could factor it. But 3 not being positive, not factorable. All right, so after you plug everything in, bless you, underneath our square root sign, negative 4 squared is 16, then negative 4 times 1 times 3 turns that into plus 12, so that's where my 28 comes from. Directions told us simplest radical form, so my perfect square that comes out of 28 would be a 4, square root of 4 being a 2. That's how that turned into 2 radical 7, connecting it back with last unit. And then just reduce. 4 divided by 2 gave me 2. 2 divided by 2 gives me a 1. But being a coefficient, we don't have to write that 1. So. Okay, let's try some more examples on the back. This one says for values of x to the nearest tenth. So you'll be able to put this one in your calculator, and they want you to round to the nearest tenth. So what do we want to do for this one? You gotta cross multiply. One fraction equals one fraction means we cross multiply. So the 2x minus 1 times x plus 1 equals the 1 times 3, so 3. Go ahead, distribute out that left side, get yourself a trinomial. All right, let's take a look at that fourth one. It says solve the equation 2 times x plus 3 equals negative 5 over x. And express the roots in a plus bi form. Those imaginary, they're still here. Still going to get those as answers for some of our quadratics. So what should we do first for number 4? One thing we could do is we could cross multiply. Remember, everything is over a 1. We just don't always write it. So instead of 2 times x plus 3, it'd really be 2x times x plus 3 equals 1 times negative 5, so negative 5. So distributing our 2x, so we get 2x squared plus 6x. And then add our 5 back over. And then let's have you practice. Plug that into your quadratic formula. See what you get for your answer. All right, so when we plug in, under that radical, it ends up being a negative 4. So that's where our I comes from. Square root of a negative brings you your I. So the square root of negative 4 is 2I. Can I reduce these? Yes. Yes, because remember, I is imaginary. It's not a real number. Okay. So each of these can be divided by 2. So that gives us negative 3 plus or minus 1I all over 2. Just so you can get familiar with it, sometimes if it's a multiple choice question, they'll separate it out into 2 different fractions like this. So they put that first term, negative 3, over the 2. The 1 that's in front of I that we don't always write, they'll also put that over 2 and then put the I after it. So you just have to keep in mind that these are really the same thing. I'm never going to make you separate it. It's just, as I said, on a multiple choice question, especially on the Regents, sometimes they do that. So you just have to be able to recognize that it's really the same thing. What do we got to do first for number 5? Common denominator. What's it going to be? X. That second one already is over x. So that's going to say it's 3 over x. The other ones both have to be multiplied by x in order to get that common denominator of x. So we get x squared and the 2x there. So I would subtract my 2x over, which is how I get x squared minus 2x there. And then plus your 3 equals 0. And go ahead, try it again. Plug it into the quadratic formula. Our directions give us the hint that it's going to be imaginary, again, because it tells us in a plus bi form. That's what you should end up with, is 1 plus or minus I radical 2. So we ended up with this negative 8. Not a perfect square in itself, but we can take out the perfect square of 4, which is why we have a 2 out in front of it now, and then it was negative, so there's your I. Then 2 divided by 2, and then 2 divided by 2 again to reduce it. So in our last way to review completing the square is my personal favorite one. It's just a shortcut really to the quadratic formula. So that's why I always do it after the quadratic formula. The main thing with completing the square is you need to have perfect square trinomials. So perfect square trinomial, what that means, and I got 2 examples right here. Your last term is a perfect square always. Your first term is also always a perfect square, so x squared, even exponent, that one's a perfect square. If I were to square root 100, that would give me 10, and then if I double it, that gets you your middle term. That's the pattern it follows. So this one, square root of 64 is 8. You double it, there's your 16. So that's another perfect square trinomial. Here's another one, 49 perfect square. Square root of it is 7, double 7, middle term is a 14. So that's always the pattern that it follows. Does anybody remember how we calculate our C value? I think we did this a little bit last year in geometry, more so in Algebra 1. Yeah, take your B value, divide it in half, and then square it. That's how we actually find our C value. Now, the reason why we want to use those perfect square trinomials is because they factor in a very specific way. So this one, x squared plus 20x plus 100, how does that factor? X and x, and then plus 10 and plus 10. So back when we did factoring in Unit 1, I kept telling you, how do we rewrite that? X plus 10 squared. So I generally tend to skip that middle step, and I go right to the x plus 10 squared, because that's the whole point of getting that perfect square trinomial. So if we look at my other example here, x squared minus 16x plus 64, how would that factor? X? Yeah, that would be x minus 8, x minus 8. So x minus 8 squared. So that is why we use those perfect square trinomials. So again, I have written out here for you the steps. I prefer to actually go through it myself instead of reading through the steps. So let's take a look at our first example. X squared minus 2x minus 24 equals 0. So is 24 a perfect square? No. So I'm going to move that over to the other side of the equal sign. And then I'm going to put an empty space after my 2x. And I'm going to put an empty space after my 24 over there on the other side. Some people actually draw boxes. I don't like to confine my writing, so I put spaces. So again, as we were saying, so we're going to take our b value, which is negative 2, divide it in half. We get 1, and then square 1. And that's what goes on the line. So now we do have a perfect square trinomial, x squared minus 2x plus 1. That factors into x minus 1 squared. On the other side of our equal sign, we get a 25, because 24 plus 1, 25. So now this is like our first page. My thing that is squared, x minus 1, it's by itself. So I'm going to take the square root. And when I take that square root of 25, it becomes plus or minus 5. Because the square root sign wasn't there, we introduced it. You got to have both plus or minus. And then we add over our 1. So it becomes 1 plus or minus 5. Now, can we actually add 1 and 5? Yeah, so we got to do that if it's possible. So 1 plus 5 is a 6. And then 1 minus 5, negative 4. Our two answers end up being 6 and negative 4. All right, number 2, 11. Is that a perfect square? Nope. So I'm going to move that over and put my spaces. So x squared plus 6x plus a space equals 11 plus a space. What goes in the space? 9, because half of 6 is 3. 3 squared is 9. So then how does our left side factor? Plus 3 squared. 11 plus 9 gives me 20. Then I take the square root of both sides. Yep, perfect square that comes out of 20 is 4, which turns into a 2 when I take the square root of it. So I get 2 radical 5. Last step with that 3, subtract it over. Perfect. Negative 3 plus minus 2 radical 5. All right, third one is 8 perfect. Nope, so we'll bring that over. This time we're going to have to subtract it over. So it would be negative 8 plus a space over there. So what number goes in our space? 4, because half of 4 is 2. 2 squared is 4. So then our left side would factor into x plus 2 squared. Right side, negative 8 plus 4 gives us a negative 4. Now what? Square root, so we get x plus 2 equals plus or minus 2i. Because again, square root of a negative makes it I. So then we subtract our 2 over, so our final answer, negative 2 plus or minus 2i. So in our last one there, number 4, we cannot do completing the square with that being a 3x squared. Completing the square only works if it's a 1x squared. So what can we do to accomplish this? Greatest common factor, or divide everything by 3. So it gives us x squared minus 4x minus 7 equals 0. Now we can do our completing the square. So I move my 7 over, put my little box there. What number goes in the space? 4. The left side factors into x minus 2 squared. Right side adds to give us an 11. Now there's no perfect square that goes into 11, so that's just going to stay as plus minus radical 11. And then we add our 2 over. And there's our final answer.